Hello, everybody. Today we're going to talk about hypothesis testing, which is kind of a culmination of the course. With hypothesis testing, we're going to have a 5-step process when we talk about hypothesis testing. The first thing that we have to be able to do is identify what is the hypothesis. What is the researcher, trying to claim? Is he trying to prove a hypothesis where it's going to be a greater than situation, a less than situation, or a different situation? So the format that we always do in step 1 is we identify what we call the null hypothesis, the HO. That is always in the format of the mean equals. The alternative hypothesis, which we claim as H1, is either going to be the mean is greater than, the mean is less than, or the mean is not equal to, depending on the wording in the problem. So the example that we're going to use, which will be in your Google Classroom, is the hypothesis testing quiz, which obviously isn't a quiz, just a practice paper. But number 1, it says salaries for actuaries. Central Connecticut State University graduates entering the actuarial field earned $40,000. A college placement officer feels that this number is too low. She surveys 36 graduates and finds their average salary to be $41,000. Standard deviation is $3,000. Can her claim be supported at a level of significance of 5%? So after reading that, what they're telling us is that the actuaries are earning $40,000. So that is the null hypothesis. She feels that this number is too low. That's her claim. So if she feels that that number is too low, she feels that they're making more than $40,000. And that is going to be her claim. That's what she's going to try to prove through her hypothesis test. So that is always going to be our first step. What is the mean equal? That's the null hypothesis. What is the alternative hypothesis? In this case, she's claiming that it's going to be greater than. So we always want to identify what the claim is also, because that's going to be important later on. So step 1 is done. Step 2, we're going to draw a picture and we're going to state what's called the rejection rule. Now, if you have a situation where it's a greater than or less than, those are what we call a one-tailed test. Greater than will always be on the right-hand side. Less than will always be on the left side. If it is a two-tailed test, that's when it's a equals not equals problem. And we would take our level of significance, whatever they tell us in the problem. In this problem, they told us that the level of significance was 5%. So this little symbol that we use here, the level is 5%. So for this problem, because it's a greater than, I'm not going to have it on the less than side. So again, what do I do to figure out what the z-score is? If your area is 5%, well, what's 1 minus 5%? 95. If you look up 95, the z-score that's going to be closest to that is 1.65. That's that one that falls between 164 and 165. So what we're going to say is that we are going to reject the null hypothesis if our z-score is greater than 1.65. And what we're basically doing here is we're setting up ourselves for step 3. We're going to come back to this step after we do step 3, figure out what our z-score came out to be, and that's going to tell us whether we're going to be able to reject the null hypothesis or not reject it. Now, if we were doing this problem and we were doing a two-tailed test, well, then you would just take your level of significance and cutting it in half, and you would have 2.5% on both sides. And if you look up 2.5%, it's a negative and a positive 1.96. But again, for this problem, we're focusing on just the one-hand side, the right-hand side. So that is setting up the problem. now in step 3, okay, we're going to go back to our formula that we've been using, the one that we did with our central limit theorem, and finding the z-score. So in this problem, we already know that they feel that the actuaries make $40,000. Okay, now when you read the problem, it says when you surveyed 36 actuaries. Okay, so in her research, the sample size is 36. Those 36 people were making $41,000. Okay, so again, sample mean. And the last piece, okay, the standard deviation they told us was $3,000. So the numerator is going to be 1,000. The denominator, 3,000 divided by 6, is going to be 500. So 1,000 divided by 500 is a z-score of 2. Okay, so go back to step 2. Step 2 said if our z-score was greater than 1.65, we would reject the null hypothesis. Well, our z-score is a 2. So since 2 is greater than 1.65, we are going to reject the null. Okay? If this had come out to be 1, we wouldn't have rejected it. But because it was 2, we are going to reject the null hypothesis. So if I go back to this step over here, okay, what I'm saying is this statement we're rejecting. Okay, we're saying that that is not true. So therefore, we're saying that what she claimed is true. There's enough evidence to support the claim that the actuaries do make more than 40,000. She was right. They were making, it was too low what they were saying. Okay, so when you state your last step, okay, your conclusion has to be based on the claim. And the wording that you have to use, and yes, you do have to write a little bit of a sentence, a little bit of a paragraph, okay? There is enough evidence to support the claim, or there is not enough evidence to support the claim. So in this case, we would say there is enough evidence to support the claim that they make more than $40,000. Okay? So with hypothesis testing, it always starts with what are your hypotheses, okay? And then what we're basically trying to prove is there a significant difference, okay? In the sample, in those sample of 36 actuaries, there was a significant difference here. So when there's a significant difference, you can reject the null hypothesis, okay? And if you're able to reject the null hypothesis, then we could say that there was enough evidence to support the claim, okay? In the next video, we will do a problem where there is a two-tail test, but this was a one test sample.